Hello everybody, my name is Bettina Duran and today we are conducting the first part of the training workshop on biological waste treatment with the MYT technology, the maximum yield technology, which was developed in Germany. But today we will have the part 1 and we will have a deep insight into the different types of waste. Here in this slide we just show you what is the content of the entire workshop, and as you see we will focus on the different types of waste because you need to know your waste before you can design your waste treatment facility. So, and the content of the workshop today is we will see how waste can be put into different categories and what kind of waste types we came up here in Germany with. We also will have a look into waste quantity, what this really means. Also the composition of waste, and we will also see how a sorting analysis is conducted. So what is part of a sorting analysis, what have you to respect, how to prepare, how to conduct it. And then in the last part we will also have a look into the different types of waste. So also waste which contains bio-waste. So we will see the mixed municipal solid waste, which normally has a share of bio-waste between 30 and up to 70%, depending on the country. Then we will have a look into the separate collected bio-waste, how we do it here in Germany, what are the advantages, what can you do with waste when it's separate collected, the bio-waste of course. We will have a look into the agricultural waste and also in kitchen, restaurant waste or food waste, because also in Germany we have distinctions here. So, but let's start with the waste types and categories. Why is this so extremely important? Because waste is never equal to waste. And when you know where your waste comes from which industrial process, from which kind of activity, it tells you a lot about how this waste, what is inside this waste, maybe how are its characteristics. So this is why we came up in Germany with a German Waste Catalog Ordinance oder die Abfallverzeichnisverordnung AVV, and I please want to apologize right away. It becomes now very German, very detailed, but we want just to show you how far you can go with such those categories. And also what you need to know is that waste management requires really a detailed distinction between the various waste types. Yes. So in the Abfallverzeichnisverordnung or the German Waste Catalog Ordinance, a waste is assigned to a waste type. And we form a 6-digit waste code and a waste description. And like I already said, in Germany we have 842 different waste types. And you see this small blue picture which explains this waste catalog for you. So the first 2 digits are the chapter, the second 2 the subchapter, and the last 2 the individual entry. And when you see the asterisk, as you can see here on the blue box, you know directly that this waste is a hazardous waste. But we go more in detail on it on the next slide. So, like I already said, the hazardous waste in the European Waste Catalog is identified with an asterisk. So you know directly you have to take special care of this kind of waste. The first, then you have the absolute entries. So the waste is always classified as hazardous. And you have an example like inorganic wood, preservatives, waste paint, or waste including asbestos. So you know this waste is hazardous waste and you have to treat it with care. And then you could also have mirror entries of waste, hazardous waste material. So the hazardous material is classified as contaminated with a certain substance. So we just started with the most difficult part of this waste ordinance, but just that you know how to take care of hazardous waste. We have an example here. For example, the mirror entry, or we have here the example of wood. So wood would have, if it's an untreated wood, a raw wood, it would have, it would be in the category wood, which is 17, subchapter 02, and then 1 is the number to classify the wood. If it's treated wood, containing, for example, glass, plastic, or other contaminating substances within the wood, it has an asterisk right away, and you know that you will have to take special care of this wood and that you cannot burn it in any, furnace. So I wanted to show you the 20 different chapters. And I will not read all of them to you, but I just want to show you how we made our distinction in Germany. So we have waste from mineral resources, from agriculture, from wood processing, which is different than waste wood, from textiles, oil refining industries, from chemical processes, inorganic and organic ones, and also from coatings, adhesives, sealants, so which comes mostly from the industries. We have waste from the photographic industry and waste from thermal processes. So this is the first half, and then the next slide, I show you the second half of our ordinance. So we have waste from surface treatment, from mechanical shaping processes, oils and wastes of liquid fuels, organic solvents, packaging waste. We have also a category for waste which is not specified elsewhere. We have a construction and demolition waste, waste from medical or veterinary care and research, and we have also waste from waste treatment plants. For example, if you produce an RDF, it is still waste from the German categories, and it would have the number 19. Because it is a material which originates from waste treatment facilities, and this is why it receives the chapter 19, or the two numbers 19 in the beginning. And of course we have the municipal solid waste, where everything is in, so household, industrial, light industrial, commercial waste, and also the separate collected fractions. This is how we set it up in Germany, just to give you an idea. And so we can distinguish where our waste comes from, and this gives us also knowledge how to treat it, what can be in, and what might be the best solution for this waste. I show you now the distinction, the subchapters of number 20, the municipal solid waste, so the household waste. And also the separate collected fractions are in there, and you see how far as it goes. We have the paper and cardboard, glass, textiles, but also pesticides, drugs which can be in this waste, wood, metals, plastics, waste from road sweepings and market wastes. You just name it. When you go through this list, you see that is actually these are all the materials which you can find in municipal solid waste. And now we go over to waste quantity and waste composition. So if you want to set up waste management strategies, or if you want to design a waste treatment facility, or it doesn't matter, whatever you want to do with your waste, or if you want to establish a master plan for your city, you need knowledge of your waste quantity, of its composition, and of course of its physical, chemical and biological characteristics. And I will also show you how you get the knowledge of the physical, chemical and biological characteristics. It is not only needed for the development and planning and implementation of waste management strategies, as I already said, it's also fundamentally important for resource and climate protection and for material flow management and also for benchmarking. And it's data which is absolutely needed if you want to push your waste management step by step towards a circular economy. So, why do you need this knowledge? If you want to plan the collection logistics, so the collection containers, so the size of the containers, the routes, and how often you have to empty the containers, this is why you need to know about the quantity and the waste composition. It's absolutely crucial for the design of the aggregates or plant elements, because you need to know the particle size, for example, if you want to know the best diameter for your holes in your sieve drum, for example. So you need to know how big your waste is. And you also need to know the water content. Do you have water flowing out of your waste because you have a very high organic content of 60-70%, like we know it from Asian countries, where just water is flowing out of the waste? Or is your waste very dry and suitable for direct incineration? This has to be decided upon, and then this is where you need your knowledge. And of course, the calorific value, which allows you to estimate if you can use it as a fuel, or if you might have to use additional coal or a petroleum to make this waste burn. And also about the efficiency of your power plant later on. You also need it for the dimensioning of waste treatment plants. You need it to review your efficiency, like collection rate of recyclables, that maybe you achieved already 80% diversion from landfills and special recyclables, but if you don't know your data, you do not know how good or how bad your efforts are already. You definitely need it also for ecological assessments, like climate relevance, GHG emissions. Landfill gas forecast, of course, for the clean development mechanism, if you would like to estimate if it makes sense to use your old landfills for biogas production and for harnessing this gas. You need it also very much to make your economic evaluation. For example, the waste fee systems. You can only set right fees for your citizens or for the industry if you know about the waste quantity and its composition. Otherwise, your fees might be too low to cover your real costs, or they might be too high and people try to find different ways to let their waste disappear. For example, in Germany, we see this from time to time because you have to pay extra for too much bulky waste. If you move, if you have too much bulky waste, you cannot, it's not collected for free. You have additional charges. And what you see sometimes is that people go to the forest and just discharge their waste there, which is not pleasant at all. And of course, you need it for benchmarking in waste management to see where your country is or your municipality, if you want to make comparisons. Okay. So this is very easy for us in Germany because we have our catalog, we have a lot of statistical data, but when it comes to international waste management, the assessment can be quite difficult because very often there is no statistical data available on quantity and composition of the waste. And we have also different problems or additional problems because waste types are given sometimes different names depending on the country. And this is then difficult if we have to make comparisons in international, on MSW generated by specific inhabitants or in a specific country. What could help is the definition of the World Bank. They have definition for different groups of waste, as you can see here on the link. That would be helpful, but we have no guarantee that it is implemented. But at the beginning of a project, this terminology can be used to find a common understanding of what we are talking about here. Okay. So if you do not have this information about your waste, but you want to be sure that you're planning the right next step for your waste management, a sorting analysis could be your solution. So how is a sorting analysis conducted? First of all, you need a sorting station, a place where you can conduct your sorting analysis. So let's have a look what is needed for a sorting station. You need a place for sorting the waste which you want to examine. It is wonderful if this place has also sanitary facilities, like changing rooms for washing hands, the use of toilets, and maybe also showers, because waste sorting is not such a pleasant thing to do. And often or sometimes these facilities are just not available because you do your sorting at the local dump site, but it would be much better if you can find a place where you have a hall, because that would offer protection from weather and gives also space for storing the waste and also for executing the sorting. And it is also a wonderful weather protection if you can combine it with a good ventilation, because the good ventilation helps to bring back to avoid that the odor nuisance enters too much into your system. And the weather protection can be also crucial if you have a very hot area with a very strong sun. Then sorting becomes a very hard job, and also when it's too cold or too windy, it's not nice. And of course, you should have working equipment. You need various sieves, sorting tables, equipment scales, protective working clothing. But we have a deeper look in the following slide. So how is this sorting analysis conducted? So first of all, you need fresh MSW. And this freshly delivered waste is received directly at the landfill site, or collected and weighted on site or in the sorting hall, just at the place where you decided to conduct your sorting analysis. You should also know the number of people whose waste is sampled, because this gives you a good estimation on the amount of waste per person. Just to verify also these numbers, because you find these numbers in literature, but it is not necessarily correct. So it's wonderful if you have literature and indication, and when you conduct your own sorting analysis, you can verify those numbers, or you know that in your area you have different numbers. And what you also should integrate is the support of the local disposal company or the waste collector, because the disposer knows what, when and where the waste is taken, and he can also help with the collection of the samples. And after the sorting, you need the local disposal company anyway, because they must take back the waste and dispose it normally on the landfill site. And you should take some time prior to the waste sorting analysis to make the choice of the collection areas and the times and the exact procedure. So you should determine in which areas of the municipality you want to go. So you want to have the waste from the richer areas, and you also want to have the waste from the poorer areas, because they don't look alike. You should also respect the time in the year, because summer, winter makes in some countries a big difference. And maybe also respect Ramadan, because sometimes Ramadan in waste management has to be seen as an extra season, because you have extreme increased amount of food waste. So this has to be taken into account. And also sometimes some rainy and not rainy seasons. So this has to be respected and a good procedure being planned. You can conduct a waste sorting analysis, of course, only one time, which gives you a good overview. But sometimes these analyses are done, for example, in every season or 4 times a year, just to see if there are big deviations in the numbers. And just to let you know how you start, of course, first you have to open the bags, and after You open the bags. The waste has to be sieved. Domestic waste consists of components of different sizes. This is the reason why we are sieving the waste. And these size classes often have different properties. So the size distribution is also of interest for the later treatment process. As I told you earlier, you need to determine the diameter of your holes in the sieve drum in the beginning of the separation process. And this is why you find out in the sorting analysis about the size of the different wastes. Here, in this example, we made two screens, one with a diameter of 100 millimeter and one below with a diameter of 30 millimeter. So the screening, as you can see it here on the picture, is done with flat screens. The sieves, of course, must be available or built on site, must be available prior to the sorting analysis and can be built on site because it's quite easy. You need only about 1 square meter of a sieve. That could be a frame covered with wire mesh, iron mesh, or for perforated plates with a square holes if possible, according to the dimensions you want to have. And then, as you can see here in the pictures, you put the waste on the first screen, and that gives you the coarse waste fraction, which is then later on sorted by hand. Then between 100 and 30 millimeter, you get the medium waste fraction, which of course is also sorted by hand. And below 30 millimeters, you have the fine waste fraction, where only 10% is sorted by hand, because I show you a picture later on. In the fine fraction, you do not have so much to sort. There's not so much in, and you use this, of course, you use all 3 fractions for analytics in the laboratory, but we come to this later. You do not have to determine 100 millimeters and 300 millimeters every time. You can set your diameters to the number you want. Sometimes 120 is a good size, or 80 millimeters is a good size. It also depends on how sophisticated you want to execute your waste sorting analysis. And of course, before the sorting, the waste is fractionated with 1 or more screen cuts, as I already told you, resulting in 2 or more screen fractions. So the screening is done before the sorting. So the procedure of the sorting analysis. So both the fresh mass fraction and the dry mass fraction must be determined. The water content of the individual screening and sorting fraction must also be determined. For that, you need drying cabinets, which have to be available prior to the sorting analysis. But the drying cabinets gives you the water content and also the dry mass fraction. Drying cabinets can be built on site. This is also very easy, because it's normally not available. But if you are interested in building your own drying cabinet, you just get in contact with me. I send you the description how to set it up. And then with the fine waste, like I already said on the slide before, it is only determined as a mass fraction, and only 10% of this mass fraction is sorted, to give you a rough overview over the composition. The screen fractions are always sorted into various subfractions, so you need containers that you can put the different, that you can keep the waste of different origins separate. When you look to the pictures, you see the different plastic containers where the different waste types go in. If it's possible, you should also determine the bulk density of the waste fractions. And all parameters that are of interest for the design of the waste treatment plant should also be determined. So as said, the screen fractions are then sorted into sorting fractions, and this is this you agree with your client, or better with the depending on what kind of treatment facility you want to set up. So what is quite useful for a treatment facility are 12 fractions. I show you them on the next slide. But the analysis can go also much deeper and sort into 49 fractions or even more. And then this gives you a much more detailed understanding of your waste. But just for a normal average waste sorting facility or waste treatment facility, 12-16 fractions are more than sufficient. So here you can see now the 12 main fractions to be sorted from the screen fractions. We will distinguish between vegetable food, animal-based food, other organic waste, paper and cardboard, glass, plastic, textile, metal, hazardous material, indefined material, other mineral waste, and the fine waste, which is below 30 millimeters. Why do we want to distinguish between vegetable food, animal-based food, and other organic waste? This indicates us about the gas building potential of this organic waste. So this is why we distinguish it. And here you can see we have different screens. So we have a screen with 150 millimeters, and we have only one screen here. It's 150 millimeters, and we distinguish only bigger than 150 millimeters and smaller than 150 millimeters. And so now I show you some pictures from a waste sorting analysis we conducted in Sri Lanka. Sri Lanka is known for its high organic content when it comes to Colombo, so to the capital city. So we were expecting a quite wet waste with high organic content when we came to this place. But this sorting station or the sorting place was not in Colombo. It was in Trincomalee, which is on the other side of the island, so in the northeast. There we have a different climate, and it's a rural area. So the waste was then quite different as we had expected it. So first you see the kitchen waste, which is below 150 millimeters. You also see the other organic waste, so the coarse waste and the finer organic waste. And you also see on the picture below the elephants which come to this dump site every evening to feed on the organic waste, and they love the banana, which you can see on the other side, on the other pictures. There is a lot of banana leaves and trunks inside this waste, this organic waste fractions. Then you can see the paper and the cardboard, the glass, plastics, textile, metal, the hazardous material, the other mineral waste, and the fine waste. And I think also to you, when you see a heap of waste, you see certain materials, but you do not know really what is in there. After you conducted such a sorting analysis by size and by fraction, you gain a much better understanding how your waste looks like. And for example, if you look towards the fine waste, you see mostly minerals and also earth. And if you have a very big amount of this fraction inside your waste, it doesn't make sense to burn this kind of stuff. So you would like to exclude the minerals and the fine waste from your incineration process, of course, as well as the other minerals and metals, which do not make sense here. And when you comes to the plastic, you see that you have still enough material for recycling, which you can use differently. So you have to be careful when you're conducting your waste sorting analysis regarding the occupational health and safety, because conducting a waste sorting analysis is endangering. The sorters can get in contact with materials and articles which are contaminated with biological agents. The risks arise in particular by smear infection, by formation of biological aerosols, and cuts and puncture wounds. So actually today it's nothing new anymore to us to wear a respiratory protection mask, but it's really important for the sorting analysis, and it should actually be exchanged every day. You should also wear puncture-resistant protective work safety shoes, because mostly these sorting analysis are conducting also on landfill sites, and when you walk through landfills, it's important that you have good shoes. You should also have protective clothing covering the whole body, and if possible, one-way overalls which you can change daily. You should also wear moisture-resistant aprons and puncture-resistant nitrile gloves if possible. Additional, it's good if you have underneath the puncture-resistant nitrile gloves, if you have laboratory gloves, which you can change daily. And you should have hand disinfectants and worktop disinfectants nearby. So what do you need as sorting equipment? Just to give you an example, you need drying cabinets, and like I said, they can be easily built, and you cooperate with the local university, and you need about 2 cubic meters of drying volume to dry your samples. You need the vibrating screens, which can be built on site. You need approximately 3 sorting tables, because if you have 6 sorters, if you have more sorters, which makes it more pleasant for everybody, you need, of course, more sorting tables. Then you need about 20 sorting crates per sorting table. You need a table for documentation of the masses. You need a larger scale, and you also need a smaller scale for weighting than the sorting boxes. And of course, you need shuffles, rakes, and forks, at least 4, but that also depends on the number of sorters. You need at least 6 boxes for collection of individual samples. You need a knife for cutting the waste bags. You need sticks or rods for sorting tables for safe pre-screening of the waste, to push the waste over the screens. You need extension cables depending on the sorting location. You should take care of additional lighting, that you have good sight. You need the bags for samples, and it's also very handy if you have some clamps at hand to be attached to the sorting boxes. So, and then you have determined the total number of samples you want to who should be analyzed in the laboratory. So normally, or an average, 15 samples will do. So if you have 3 sieve fractions. So then from each sieve fraction you would take a sample on 5 days, and that makes 15 samples which go to the lab. What are you going to determine in the laboratory? The laboratory analysis is for the physical, chemical, and biological properties of the waste, and this is done in the lab. And for the investigations, the samples are taken from the sorted waste, and then they are pre-dried. On site, you can only determine the water content with the drying cabinets, and from the different sieved fractions, of course, the samples will be taken to Germany and analyzed. So, but what are the parameters which are of interest to you if you want to determine the physical and chemical and biological properties of the waste samples? You want to know the net and gross calorific value, of each sample. You want to know the ash content, the water content in the dry matter, the organic matter, the carbon, hydrogen, oxygen, nitrogen, and sulfur analysis, which is the elementary analysis, the chlorine content, mercury, cadmium, lead, zinc, chromium, and other heavy metals, depending on what kind of sorting facility, waste treatment facility you want to establish. Okay, so that was our part on the waste sorting analysis. Now we will have a look into the mixed municipal solid waste. So what is mixed municipal solid waste? It is waste which comes from private households or similar establishments, like malls, offices, whatever. The waste should be similar to household waste from trade or industry. Here you have the examples: waste from doctors and lawyers, from administrative buildings, schools, kindergartens, hospitals, nursing homes. Also the bulky waste, market waste, street sweepings, bio-waste, separate collected recyclables such as glass and paper also belong to the mixed municipal waste. And it can also include excrement and sewage sludge. When it comes to the mixed municipal waste in Egypt, you find quite a lot of literature in the internet, and you see that in average you have about 60 to 50% of organic waste, 8 to 12% of cartoon and paper, 10 to 15 is plastic, 1 to 3 is glass. Then you have metals and also fabric. But depending on the area, if you look to, for example, to Cairo, you find a different waste characteristics as you have it for whole Egypt, for example. So depending on the location of your future waste treatment facility, it is wise to conduct a waste sorting analysis to know the exact fractions and characteristics at this special site. And I also found this information on the internet concerning Egypt. So the mixed municipal waste seems to be currently still openly dumped for more than 80%. A small fraction is composted, also a small fraction is landfilled, and a part of it is also recycled. But when you look to the characteristics on the other side, having 10% of paper, 13% of plastics, 4% of glass, and 2% of metals, I would say that the recycling rate could be much higher, also with this kind of waste. Let's have a look towards separate collected bio-waste. And of course we will have a look here towards Germany, because we have the separate collected bio-waste by law since quite some time. There are exceptions in Germany. For example, all the citizens which are connected to an NSWMP treatment facility, they don't have to collect their bio-waste separately. It does not give any benefit or advantage, and the system requires the fresh bio-waste to function. But to NSWMP we come in a short while. So the separate collected bio-waste can include all, or includes all waste of animal and vegetable origin. And in general, bio-waste is divided into the following categories. You have domestic bio-waste, which is also called bio-good in Germany. You have the green waste or greenery, which is more from landscaping. Which is more from landscaping, but more in the gardens, you know, when the people cut their own grass or their own bushes in their gardens. And then, of course, you have the park and landscape maintenance waste from the municipal sector, where you have also trunks, branches, wood, different kind of material. So in Germany, we have a bio-waste share of 30 to 40% within the municipal solid waste. This separate collected bio-waste is used in Germany for composting or for fermentation in facilities. And what we can gain out of this composting and fermentation facilities is a good compost, a quality compost, which improves our humus balance and the soil, and it replaces mineral fertilizers, which could be also a wonderful option for Egypt. But through the separate collection of biowaste in a special bin, the pollutant content of biowaste compost is 95% lower than the pollutant content of compost produced from mixed household waste. The effort of producing compost is only justified, in my opinion, when you have good biowaste, which means separate collected biowaste from markets, from households, from restaurants, from hotels. That doesn't matter, but it has to be separate collected. Otherwise, the compost which you can produce from this material will be waste compost, which you should not use for agricultural activities, because the heavy metal content, the pollutant content can be extremely high, and it's not really advisable to bring these pollutants into our food chain. So if you want to create compost, then please only from separate collected biowaste. Otherwise, if you make compost from municipal solid mixed waste, it has no value and it is not good to use it in the fields. I just want to make this point very clear. Here, this is also the perspective which we have in Germany. We do not look onto the nutrition side of the compost. We look onto the limiting values for heavy metals. So if you can produce compost of different qualities. If you have quality A, you are allowed to have a higher content of heavy metals and pollutants. If you go to compost quality B, it's more strict. So, and this also determines how much of this compost you can bring out to the fields per hectare, per year, or in 5 years. It depends only on the heavy metals. So when we talk about compost, which originates from waste, we do not look towards the nutrition side of the compost. At first we look to the heavy metals and to the pollutants, because we don't want to have these ones in our food chain. We don't bring this to the fields. In Germany, the waste compost can only be used to cover old landfills, for nothing else. So, just to give you the history, we started in Germany with a separate collection of biowaste in 1985 already. So we have 36 years of experience in this field. And the separate collected biowaste is transported to special biowaste treatment plants. So they are composted with oxygen, this is aerobic, or they are fermented. This is without oxygen, anaerobic digestion to form biogas. So in 2017, just to give you the numbers, we had 15.8 million tons of biowaste. And from this amount of waste, we produced 1.5 million tons of biowaste compost, 2.0 million tons of green waste compost, 3.8 million tons of digested and composted digested, 0.3 million tons of sewage sludge compost generated and delivered to users, and also 626 million cubic meters of biogas were produced in the fermentation plants we have in Germany. What you also need to know is that we do not only use our municipal solid waste for our bio-waste treatment plants in Germany. Of course, a big part, the lighter green part, is the bio-waste which comes from the households. But we have also liquid manure, slurry and stable manure, which goes into our bio-waste treatment plants. We have waste and sludge from agriculture and food processing, which goes to the bio-waste plants. We have waste from wood processing, we have municipal sewage sludge, garden and park waste, bio-waste, of course also food waste from canteens and restaurants, and also from other sources. So this is interesting for you to know, because here our waste treatment facilities are used for municipal solid waste, for the separate collected bio-waste, but also for industrial wastes from agricultural or processes, for example. Here we want to look into the recovery routes for biogenic waste. So, because this is determined by its composition. If you have wet bio-waste and food waste, this is a very suitable waste for fermentation with biogas utilization. And of course, then you can do recycling of the fermentation residues. If you have wood-containing components or green waste, so wood, you don't think about biogas utilization because the lignin is not suitable for biogas production. Of course, there's a lot of inventions also in the biogas sector, and there are now additives which you can use to increase your biogas output, also with the more difficult materials. But you have to see your business model first, if this makes sense, because if you have extra costs for additives to increase your biogas yield, you have to make a surplus of biogas which justifies your costs for using or for buying these additives. So you really have to look into your business model always prior to make a decision if you add something on your treatment process. And of course, for lignin and cellulose-rich plant material, composting and the production of a quality compost is the best application. So in Germany, we have about 1,000 composting plants and about 100 pure bio-waste fermentation plants. And this also indicates to you that a country with 80 million inhabitants cannot operate with 1 or 2 or 3 waste treatment facilities. There are hundreds of treatment facilities really needed to come up with a good mix, which gives you flexibility and to really process your waste and to make landfilling more or less obsolete. A large proportion of bio-waste has been composted in Germany in the past. But when you do only the composting, you cannot harness the energy which is inside this waste. The aim is to increase the proportion of suitable bio-waste which can be fermented with biogas production in the future. So this is what we do in Germany. We see if we can upgrade composting facilities with a fermentation plant prior to composting, or we see that we get more material which is suitable for fermentation. Here on this slide, you have also the graphic, how to deal with the waste. So you have the bio-waste, which comes in organic waste bins, or which is from garden or parks, or which can also be food waste. So if you go to the top, if you have solid structure-rich plant material, which is only moderately humid, it's wonderful material for compost. If you have an easily degradable, low in structure, solid to liquid material, which is for example, food waste, it's wonderful for composting. No. It's wonderful for creating biogas and digest it. You'd bring it to a fermentation plant. And if it's a dry wood-rich plant material, which you have from cutting of scrubbery, for example, you use it in a biomass power plant. And of course, you get ash and fertilizer, which is fertilizer, and you get the energy. So, how about the costs if you collect biowaste separately? As you can see here, the use of fermentation and composting plants also makes sense economically. If you compare the costs of a biological process with the costs of incineration, the cost for biological waste treatment is extremely lower. We see in Germany the waste incinerators take between 100 to 120 euros per ton of waste. These are the gate fees they need to operate cost efficiently. They used to take even much higher prices in Germany, so about 190 euros per ton. But now we have more. But now the contracts are not running as long, and you get better conditions right now. But when you compare it to the biological treatment, which is only 40 to 100 euros per ton. And you should also see one additional point. If you incinerate bio-waste, you are mostly burning water. So it does not make sense to treat bio-waste with incinerators. Bio-waste should have a biological waste treatment. But however, these additional administrative and logistical efforts, because you need another vehicle, you need another route, you have to plan that, this is quite an effort, and and also the costs for additional containers. This can only be justified if you have bio-waste material of a good separation quality, which allows you to achieve a quality compost, or where can you harvest a lot of biogas in your fermentation plant. If the separation quality is not good enough, or if you can't collect it separately, then better think of an MYT system, maximum yield technology, where you can use the residual waste together with the bio-waste in one process. Let's have a look to the agricultural waste. So the agricultural waste results, of course, from agricultural operations, and it consists of manure, oil, silage plastics, waste from farms, from slaughterhouses, harvest waste, of course, veterinary medicines, fertilizer, pesticides, herbicides, which run off from the fields, also pesticides that enter into air and soils, and also salt and silt drained from fields. What is interesting to know is that the agricultural waste from agro-based industries such as palm oil, rubber, and wood processing factories have increased in the last decades by more than threefold worldwide. So these wastes increased dramatically. What can be done with the agricultural waste? It can be used as animal feed, fish feed, or as a constituent in feed preparation. But many of these agricultural wastes are unsuitable for a direct consumption by the animals, so they need a mechanical or a chemical treatment. And often they are also very low in the nutritional value, and they need supplements to enrich them. Often we have a deficiency of animal foodstuff in developing countries, and this causes raw material to be imported with inherent high cost and the reduction in animal production. So it's good if you can make use of your agricultural waste as animal foodstuff. And you can transform this waste into animal foodstuff. and we show you how on the next slide. As I already said, it is often low in nutritional value, but also difficult to digest. And maybe also the size is too big and too tough for the animals to eat. And you can overcome these two problems with several methods. And I showed you this now on the next slide. You can use the mechanical treatment method. This is by chopping, shredding, grinding, moistening, soaking in water, and steaming under pressure. This mechanical method has been proved to give good results with high digestion by animals, but they were never widespread because you have very high costs, investment costs, for getting all this machinery for chopping, shredding, and grinding, and this is not feasible with small farms. If you want to tackle this mechanical treatment method, you have to set up a center, actually a center where you have these machines ready and where you can process this waste to animal foodstuff. It is not feasible to put these machines on the small farms. Maybe there's also a mobile solution we can think of together. It could also be that you go farm by farm with your mobile solution. But like I said, this is nothing a small farm can invest in. The chemical treatment method with urea and ammonia is much more feasible. This is not so costly and very easy to be done. You just add 2% ammonia or urea to the total mass of the waste. Then you cover this treated waste with a polyethylene foil, 2 mm of thickness. And after 2 to 3 weeks, the treated waste is uncovered and left for 2 to 3 days to release the remaining ammonia or urea before you can use it as animal feed. And here I put you a link where you can get more information of how to prepare your waste for your agricultural waste as animal foodstuff. And of course, when you've seen the list with all the waste which is in the agricultural waste, they have to be disposed of or treated according to what they are. But we wanted to show you that from agricultural waste, you can make also more than only producing compost or energy. You can reuse it as animal feedstuff. So the last type is the kitchen or restaurant waste or food waste. Maybe in Egypt it doesn't make such a big difference, but in Germany we have to take special care of this waste and we have to separate it from the other waste streams, and I show you now why in the next slides. So the strict separation is mandatory in the gastronomy sector as because and you also have to declare the various waste materials. This applies not only to the kitchen waste, but also to the packaging material and the residual waste. And in the gastronomy kitchen, you find, of course, the food waste and the organic waste. You find the used grease and used vegetable oil. You find glass, cardboard and paper, plastics and films, and other refuse, of course. It also, and this is why we have to treat it special, it contains parts of animals or products of animal origin, and those pose a permanent risk or high risk of disease outbreak or the spread of disease. So in Germany, this, like I told you, it must be collected and disposed of separately in additional food waste bins, and this is all regulated by the Animal Byproducts Disposal Act, which refers to whole animal carcasses or parts, and to products of animal origins that are not or no longer intended for human consumption. And in Germany, we have to apply this in restaurants, hospitals, old people's homes, schools, and other community catering facilities. We wanted to let you know how we deal with these different waste types in Germany, just to give you an understanding, an idea what you can do with it in Egypt. But now you will also learn about the MYT technology, which relieves you of much headache, because this process can treat various waste types in one process, and a separate collection of bio-waste is not necessary to make use of the energetic part of the bio-waste. Thank you so much for right now, and we meet again for the other part for the MYT technology. Thank you.